Hello, my name is Violeta, and I'm also a part of the team in which the previous presenters work. But unlike them, who have been focusing on LuaJIT, I have been working with Clang and LVM. Today I'm going to talk to you about the Clang plugin for generating declarations for the LuaJIT FFI library. And this work was also sponsored by Cisco. So, first of all, I'll give a quick introduction. I'll say something about using the FFI library of LuaJIT and describe the main goal that this plugin is trying to achieve. Then I'll say something about the usage of the plugin, talk about its main features, and describe some interesting examples. And in the end, I'll tell you something about the results of measurements that we have done. So, a quick reminder, LuaJIT is a JIT compiler for Lua. It enables binding Lua and C, which means calling C functions and using C structures from Lua code. In order to do that, you have to load the FFI library, then state all declarations that you would like to use inside Lua code, and then load the C library where these declarations are implemented. So, for the sake of this talk, it's important to mention that LuaJIT FFI library requires stating C declarations that will be used, as well as stating declarations of types they depend on. I'll explain a little bit in this example. So, if you want to use a function foo, which has two parameters, two arguments of types enumeration my_enum and structure my_struct, you have to state declarations of these parameters. So you have to state the declaration of the enumeration. This declaration can be stated as is. And as for the declaration of the structure, it's a bit more complicated because in this example, it depends on two non-primitive types for which you have to also state declarations. So in this case, these types are enumeration my_enum and a type def called int_p. So the final order of declaration that you need to state is the following. First comes the enumeration my_enum, then the type def int_p, then the structure my_struct, and in the end, the declaration of the function foo. So, the main goal that this plugin that was implemented was trying to achieve is to ease the binding of Lua and C using the LuaJIT FFI library by automating the generation of these needed declarations. So, this brings two major benefits. The first one being, in the case where you have a large C code base, and you have one side, and on the other side you have Lua code from which you use the declarations from C code, and you have generated declarations based on the C code. Each time you make changes to the C code with the plugin, you don't have to manually update the generated declarations in Lua code. And the other benefit is that resolving the declaration dependencies is automated. It doesn't have to be done manually, which can get complicated in some cases. On this example, I will try to illustrate just how complicated it can get. So this is a function which takes 4 arguments. The first argument is of type ADDR, which produces two declarations, two type def declarations. The third and the last arguments are of type bool, which produces one type def declaration. And the second parameter is of type a pointer to ADDR info, which is a type def to a structure called _header info. So this structure needs to be further resolved. It's shown here. You don't have to know the details of this structure. It just comes down to that after resolving all declarations, finding all declarations that are needed for this structure, all types that this structure depends on both directly and indirectly, it resolves to declarations of one structure, declarations of 4 enumerations, and 11 type defs. So that totals to a total of 20 declarations that are needed to be stated in order to use one function. This is an example from the Valgrind project. So the plugin was implemented using Clang. Clang is an open source compiler frontend for C, C++, and Objective-C. It offers a plugin mechanism which enables you to define additional actions to be performed during compilation process. So the plugins have access to the abstract syntax tree, and the abstract syntax tree holds all the information about the compiled source code that is needed during compilation. On this slide, we can see how the plugin is used. So the input is the source code written in C, and you have to mark the declarations that you want to use in Lua in a certain way. For this purpose, a support for a new custom attribute was added to Clang compiler. The attribute name is the FFI binding. So the idea is that you compile the source code written in C with Clang, during which time the plugin works and generates the declarations needed for the marked declarations in C source code. It's important to mention that one Lua file, and these declarations are then put into the output Lua file. It's important to note that one Lua file corresponds to one C file because that's the way the plugins work. The plugins work on one C file at a time. The Clang plugins. So some of the main features that this plugin implements are basic constructs in C language, such as structures, unions, enumerations, type defs, arrays, and pointers, and their combinations. Some of the currently unsupported constructs are function pointers, pointer fields in structures, and bit fields. Function pointers and pointer fields in structures are currently resolved to void pointer. This was a requirement in order to decrease the overall number of generated declarations, and for those types that are actually going to be used inside Lua code, you would have to mark them manually in C code. Also, it's important to mention that currently there is no support for C++ yet. Now I'd like to show you some of the interesting examples of problems that we came across during implementation of the plugin that we needed to solve somehow. The first one being the problem of forming declarations for multi-dimensional arrays as function pointers and pointers to arrays. So if you have a declaration in C, which looks something like this, so it is a declaration of a function marked with the attribute FFI binding. So this function has one argument, which is a two-dimensional array of pointers to integer. So since the compiler loses the information about the first dimension, the declaration of the parameter goes something like this. So the name is a pointer to an array of 4 pointers to integer. So if the declaration was left like this, it would be correct. So you have to add a set of parentheses. So the generated declaration looks something like this. You can see that each pointer in a type declaration adds a set of parentheses, which makes these generated declarations correct, but slightly less readable than the ones from the source code written in C. The other interesting problem was the forming of declarations for arrays of anonymous structures as function parameters. If anyone is wondering who uses this, we came across this while testing one of the open source projects written in C. Testing our plugin on one of these projects. So if you have something like this, so you have a type def, which defines a type of an array of anonymous structures called some type. And if you have a function which takes an argument of this type, this actually is automatically replaced with the pointer to the anonymous structure. So Clang gives information that looks like this, something like this. So this, of course, is not a valid C construct. So we came up with the following solution. We define a new structure with a generated name, and then use a pointer to this structure as a function parameter. This, of course, is not a perfect solution because this way the declaration for the type def is not generated at all. But given the rare use cases where this kind of construct is used, we found this to be satisfactory for now. Those were the main features that this plugin implements. Now I'll tell you something about some of the additional features. So the first one is combining multiple generated Lua files. Basically, that means that you combine declarations from multiple Lua files into one Lua file, and during that process you remove all the duplicate declarations if such exist. The next feature is the blacklist feature, or the feature of list of forbidden declarations. Basically, you can specify a list of declarations which should not end up in the output Lua file. This is used, for example, to filter out the declarations that originated from the headers of standard C libraries. And the last feature implemented is the testing mode feature. The testing mode basically ignores all the marked declarations in C source code and generates declarations for all functions found in the code. This mode was used for testing the plugin for performance. Here are the results of the performance measurement. So we used a couple of open source projects written in C and compiled them using Clang with and without the plugin, and measured the times needed for the compilation, and then calculated the percentage of deceleration that the plugin introduced to the compilation process. and the numbers went somewhere from 1 to 12%, which in our case didn't go above 7 seconds. It's very important to mention that this is the worst case scenario because these are relatively large projects, and also the plugin generated declarations for each function found in the source code, including functions found in header files. Another set of measurements that we did was we basically counted the number of generated declarations, and here you can see the numbers before and after removing the duplicates from the declarations. It is shown that the duplicates make about 90 to 98% of generated declarations, and this is because, as I said, declarations were generated for each function found in the code, and a lot of C files include standard C library headers and also headers from these projects. So these duplicates, the headers are the reason for a large number of duplicate declarations. To sum up, if you work with LuaC, if you use LuaJIT FFI library, you might find this plugin useful. So you should try it out. I have uploaded it on GitHub last night and came up with a very creative name of Lua FFI again. So you can search for it if you want to. Also, you can contact me at this address if you have any questions, and I'm also open for questions right now.
So you're using Clang just to parse C?
Yes, and to parse the C code and to find the types that declarations depend on, and then to find declarations of these types and to print them out in the right order.
In your slide 15, that there's an anonymous structure that you created a name for it.
Yes?
Why don't you put the struct declaration directly inside the function declaration?
Struct declaration. To
Yeah,
put the.
their struct open brackets int x, close brackets.
To be honest, I
You mean in line with the function?
Yes,
Yeah.
inlining the struct.
guess we could do that. I can't think of a reason right now.
Why would you want to?
To avoid creating, I mean, just why don't you want? Well, you can go the other direction too. You can just type def everything, and I thought it's funny because sometimes you do inline and sometimes.
Mm-hmm. This is just the solution we went for.
I can help right now notice the potential notice in the slide. And given that, I wonder that your project does not list any license. What license is it published?
The same license as the Clang and LVM project.
Wrong, Sam. You probably wouldn't find that very thick. Yeah, template is wrong.
Yes, sorry.
Template is wrong. Sorry.
It's not confidential.
Probably they would not be able to publish the stock because of this. Okay, thank you.
You mentioned in the
Yes?
you have to run manual
Yes, we had to add support for the Clang, so Clang would be able to recognize it. And
I seem to remember another program for GCC. I don't recall if it does exactly the same thing as this. It uses GCC to output XML, and from there you generate the binaries.
do you know the name?
I can look at another one that I made right now. So I thought maybe you have to use Clang for a particular person instead of.
It was a requirement. Yes.
Since you have a whitelist,
Yes.
it would be possible to, what would be easy to add a whitelist feature, which is instead of adding the declaration, you have one file which specifies all the functions you want in the API. But you never add the attribute.
Well, the plugin was implemented because the idea was to incorporate it into the existing build system. So the idea is to extract the declarations from the C source code. I'm not sure that I'm understanding your question. You're asking if you can specify a list of declarations that should always be generated, or
Yeah, instead of, because if you take an open source project and you want to do great binding,
okay.
maybe you don't want to modify the C source of the project. So since you have a blacklist, I was comparing it to the opposite, have a whitelist of functions that would behave as if they had the attributes. But it's a single file of capacity, very like
Well-
you don't modify the original source.
Well, to use the plugin, you have to have the source of the original software and to build it. So you don't make any modifications to the software. The modifications concerning the attribute, you mean adding the attribute to the functions? No, that is currently not implemented. Yes?
Do you have an example you could show us of the output Lua, just so I'm interested what it spits out?
No, I I thought that making a demo of running one command line was not interesting, but I was wrong.
Not much sound.
I mean, is it pretty much like you showed in one of the early slides in the
Yeah. So it looks pretty similar to the source code, but it has some differences. For example, with pointers, that is the major difference, the added parentheses. Anyone else? That's it, I guess. Thank you.